In this example, we're going to look at a couple different word problems that lead us into systems of linear equations. So when dealing with word problems, you really need to follow some simple steps. You want to read it all the way through, figure out kind of the basic theme. So in this case, it's saying against the wind, a small plane flew 210 miles in 1 hour and 10 minutes. The return trip took only 50 minutes. What was the speed of the wind? What was the speed of the plane in still air? So we've read it all the way through. We realize it's a question about a plane flying in two different directions. It's talking about the speed of the plane, the speed of the air. The next step is to draw a picture. Well, even though there's really not much to draw here, you'll get other examples where you can maybe draw a picture of some sort of geometric shape that it's talking about. But in this case, you could even have something as simple as, right, the plane going in this direction and then the plane coming back in this direction, knowing that it's the same, right, distance both ways. You can label it 210 miles, right? You can talk about 70 minutes in this direction, right? An hour and 10 minutes, and then 50 minutes back in the other direction. So we've read it through, we've drawn a picture, we've gone back and in little bite-sized pieces taken out all of the important information. We took out the distance, we took out the time in one trip, we took out the time in the other trip, and then you want to identify the questions. What's the speed of the plane? What's the speed, the speed of the air, wind, and speed of the plane? So we know we need to solve for those two things. So we can think of wind is going to equal something, and plane speed is going to equal something. Well, go ahead and give them some letters. Now you can use X and Y, as a lot of students will, but I like to use letters that make sense. W and P for speed of the wind and speed of the plane, right? Okay. Now it says against the wind. So when he first flew, this was against, and this was with. Okay, so when they flew against the wind, isn't their total speed going to be the plane's speed minus the wind? And when they're with it, it's going to be the plane's speed plus the wind. So we read it all the way through, we get a theme, we draw a picture, we go back bite-sized pieces, we pull out all the information, we label everything we can, we identify the questions, we assign variables to what we're trying to find, and then we start to set up the questions, right? We start to set up our equations. So we know that the speed in one direction, the speed in the other, and then how do we work with these things? Well, we know distance equals rate times time. So we have two cases. We have against, when they were flying against the wind, their distance, which was 210, equaled their rate, which was P minus W, times their time, which was 70 minutes. When they went with the wind, their distance, which was the same, is now a rate of P plus W and a time of 50. Okay, so now we've done all these steps. We've created or found our hidden equations. That's what I always tell students, is that when you're dealing with word problems, there's always hidden equations in there. They give you some information and you have to relate some things. And that's what we figured out with this step, is we figured out that there's this relationship between distance, rate, and time, and then we just filled in the information we had for our two scenarios. So now we have 210 equals 70p minus 70w, but we also have 210 equals 50p plus 50w. Now there's two ways you can tackle this. You can, and there's two ways you can always tackle any system of equations. You can do the substitution method, where you substitute information from one equation into the other. Usually that entails solving for one of your variables. So you would get everything in terms of p equals some stuff, or w equals some stuff, and then substitute that back into the other equation so that you get something all in terms of one variable. Or the other method is what's called the elimination method, sometimes called the addition method. And I like to do the elimination method because it's a better method when you start having 3 variables and 4 variables, which are things that happen. So the elimination method just tells us we want to stack our 2 equations like they are here, where your constant terms are stacked, right? Your p terms, your w terms. So the 2 equations are basically symmetrical as far as all the variables line up. Once you have that, the idea is to multiply your equations by numbers such that you get the coefficients in front of one of your variables to be the exact same number but with opposite signs. So for instance, you would want 100p on top and then negative 100p on the bottom, right? Or negative 50p on top and positive 50p on the bottom. But you obviously want to, kind of make it as easy as possible. Since your w's are already opposite signs, the easiest thing would just be to get these 2 numbers to match. So to get 70 and 50 to match, how about just multiplying the top one up here, right? So we can multiply our first equation by 5 and the second equation by 7, and then they'll match, right? So we're going to get 210 times 5, which is 1050. All right, 70 times 5, well, 7 times 5 is 35, so that's 350p minus 350w. Now do the bottom one times 7, so now we have 210, right, times 7, which gives us 1470, and then 350p minus 350w. Now I know some of you are sitting there yelling at your screen going, there's an easier way because they both equal 210. You can just set them equal to each other. Yes, yes, yes. But that only works for this particular example. I want to show you a way that works for all examples. And then of course, when you see shortcuts, take them. Okay, now that we have matching coefficients, sorry, this should be a plus, matching coefficients but with opposite signs, all you have to do with the elimination method, which, like I said, is sometimes called the addition method, is to add, right? So that's why these are stacked, because now you can add. So you take your 1470 plus 1050, and you get 2520. You add these two, and you get 700p. And then when you add these two, they go away. Aha! That's the whole point, right? Is you want to eliminate one of your variables, thus why it's called the elimination method. Now all you have to do is divide both sides by 700, and you get that 3.6 equals p. We now know that the plane, right, had a speed of 3.6. Now you might be thinking, that doesn't seem logical. How can a plane have a speed of 3.6 miles per hour? Well, it's not miles per hour because what did I put my unit of measure for time? Right? I didn't list time in hours. I list time in minutes. So this is actually miles per minute. This is 3.6 miles per minute. So it should feel wrong because that's not a good speed, but it's because we have a different unit of measure. And I did that because then we don't have to deal with fractions or decimals, because if we want to put this in terms of hours, right, this is going to be a decimal of an hour, as is 50, right? It's going to be 5/6 of an hour, which is an ugly decimal. So we can do this, and then we can do the conversion at the end. Okay, but how do we get W? Well, we just plug it back into either one of our equations and solve. So we can go back up here, and we can even use these that aren't factored out, and we can divide both sides by 50. And when you do 210 divided by 50, you get 4.2 equals P plus W, right? So I just took this second one and divided both sides by 50. Now I can plug in my P. 4.2 equals 3.6 plus W. So of course, subtract 3.6 from both sides, right? And you get 0.6 equals w. So now we have both of our speeds, which is what we were looking for, but most likely we want those speeds in miles per hour. So if I do this many miles per minute, then how do I figure out how many I do in an hour? Well, how many minutes are there in an hour? 60, right? So you just have to take those numbers and multiply them by 60. So 3.6 times 60, this equals 216 miles per hour. And then, of course, 60 times 0.6 gives you 36 miles per hour. Okay, so that's a typical word problem and how to set up linear equations and then how to use the addition method to finally solve them.